In this video, we're going to talk about the sum and difference identities for cosine. I've actually listed these two identities here at the top. So sum and difference means we're going to try to evaluate the cosine of one angle plus another angle. It's not as easy as just the cosine of the first angle and the cosine of the second angle, right? We have a whole formula here. And the same is true for the difference. So we're going to use that to calculate, but we're also going to use that eventually to verify identities if we need to do that. I don't like to give you formulas without giving you some justification behind them so that we're not just plugging in blindly to a formula that we've been given. I do like to kind of give you a chance to see where it comes from. This is probably the one that has the longest explanation, so bear with me, but I do want to derive the difference. I mean, this is also done in the book. You can look for it there, but I thought it might be nice to have an explanation of why it is what it is, and also an explanation of what you're seeing in the book if you are reading through it. Okay, so the book, the way that it proves that these two are equal is to draw two diagrams, two unit circles actually. So we'll start with that. And okay, on one unit circle, two angles are drawn, right? Let's see. I'm going to try and color code them. I don't know if that's going to work, but I'm going to try. So we'll say that this is angle A, starting at the standard position, and kind of going up through to there, right? So that's angle A. And we'll say that this is angle B, of a smaller angle, going from standard position up to there. Okay, so each of these generates a point on the unit circle where the x value of that point, let's do that, okay, is the cosine. So we'll have the cosine of A, comma, sine of A. I didn't write that very nicely. I didn't have a lot of colors to choose from today. So that's the cosine and that's the sine. All right, and then we can do the same thing for angle B. Right? Here would be a point with coordinates cosine of B, comma, sine of B. Okay, and we can mark the distance between the two of them, between these 2 points. And we're going to call that distance number 1, D1. All right, so the distance between these 2 points, now the angle, think of this almost like a triangle, right? The angle here between A and B is going to be the angle A minus B. Right, so from here to here is actually the angle A minus B. All right, and so this is one diagram that we're going to use, right? And we're going to calculate this distance. All right, now imagine taking that triangle and rotating it so that this side right here, we're on the x-axis, kind of in standard position. I'm going to draw that one over here in green, if you can see that. I hope you can. So it starts here. It's smaller. I'll do it like that, okay? And this is the angle A minus B also. It's just that we've rotated that triangle around to sit right on the x-axis. Okay, and now the points of interest are, the first one is on the x-axis. So this would be 1, 0. And then this point, again, would have coordinates cosine now of A minus B and sine of A minus B. And because it's the same angle in the center as this one, the distance from this point to this point, we're going to call that distance 2. But those distances should be the same. So distance 1 and distance 2 should be equal to each other. And that's kind of the basis for the proof or the derivation of this formula. All right. These drawings are also drawn in the book. It might be a little bit easier to see in the book. I don't know. Maybe yes, maybe no. Okay. We are going to need the distance formula because we're going to kind of work on that. That's where we're going next. So I'm going to just jot that off to the side. It's not related to this, well, it's not really specific to this picture. I'm just jotting it off to the side. So remember the distance between any 2 points is x2 minus x1 squared plus y2 minus y1 squared. Okay, and we're going to use that to calculate distance 1 using these 2 points. And we're going to use that to calculate distance 2 using these 2 points. So let's do that next. Okay, so distance 1 would be the square root of, let's see, let's let this be 0.1 and 0.2. Or sorry, no, 0.2 and 0.1. So we'll do cosine of A minus cosine of B squared plus sine of A minus sine of B squared. That's the distance formula for distance 1. Okay, and that must be equal to the square root of, now we're going to do distance 2. We're going to do the cosine of A minus B minus 1 squared, using the x values, plus sine of A minus B minus 0 squared. Okay, so these two are equal. Now we would like to kind of work this out in hopes that we can show that these two are equal. Okay, first of all, we can square both sides. So that's going to just give us what's inside. So the left-hand side is just the inside of the square root. On the right-hand side, we'll have the cosine of A minus B minus 1 squared plus, since this is 0, really this is just the sine squared of A minus B. Okay, now we need to FOIL all of these out. That's where the bulk of the work is going to come from. All right, so if I FOIL this out, think of there being 2 copies, cosine of A minus cosine of B times another cosine of A times minus cosine of B. If I FOIL that out, I'm not going to write it out in the interest of time. It's going to be cosine squared A minus 2 cosine of A cosine of B plus cosine of B, well, cosine squared of B. Okay, since I'm trying to fit this all on one piece of paper, I'm going to write the sign down below. Okay, same thing here. It's going to be sine squared of A. If I FOIL them, the outside and the inside together will be minus 2 sine of A, sine of B, plus sine squared of B. Okay, and then same thing here. I'm going to FOIL this out. So that's going to give me cosine squared of A minus B minus a cosine minus 2 cosine of A minus B plus 1. And then I don't have to FOIL this one because it was 0. So I'll just add down here sine squared of A minus B. All right, and then our Pythagorean identities are going to come into play. I'm going to circle them. Okay, I've got cosine squared plus sine squared, both of A. Those are going to add to 1. I've got cosine squared plus sine squared for B. Those are going to add to 1. And on this side, I have cosine squared plus sine squared of A minus B. Those are going to add to 1. All right, so that's going to give me, this is 1 and this is 1. So really that's 2 minus 2 cosine of A, cosine of B, minus 2 sine of A, sine of B, equals, this is 1 and this is 1. So 1 plus 1, that's going to be 2 minus 2 times the cosine of A minus B. This is starting to come together, okay? We have a 2 on this side and a 2 on this side. So we could essentially subtract 2 from both sides. So these are going to cancel. Now I'm going to go ahead and factor out the negative 2 because I have that for both of the remaining terms. So negative 2 times cosine of A, cosine of B, plus sine of A, sine of B, equals negative 2. I'm going to go ahead and put this in parentheses so it's really obvious. Cosine of A minus B. Now I can divide by negative 2 on both sides. All right, and I've done it, right? I've proven the identity. Cosine of A minus B is equal to cosine of A, cosine of B, plus sine of A times sine of B. All right, so that like I said, was probably the longest derivation we'll do in this chapter, but I do like to show you where formulas come from. This is kind of a lengthy explanation, but I hope it gave you kind of a basis for this formula. I won't prove the other, there were 2 of them. The book goes through kind of a rationale for that, and I'll let you look at that if you want. So let's look at a couple examples that use these 2 formulas. Actually, I'm going to do it like this. Okay, so first of all, we can calculate the cosine of angles, especially angles that we can rewrite in terms of angles that we already know the values for. 75 degrees would be one good example of that, right? So then you want to think, okay, how can I write 75? How can I break it up with either addition or subtraction into 2 angles that I know the values for? I know the cosine and the sine. And there's a couple different options here, but I think the most direct route would be to do 30 degrees and 45 degrees. Right, those add to 75, and I know the cosine and sine values for these because I've I've taken some time to remember the unit circle. All right, so we're going to be using the first formula here. The 30 degrees is going to be our angle A, and the 45 degrees is going to be our angle B. So we'll have the cosine of A, so cosine of 30, times the cosine of B, or 45, minus the sine of 30 times the sine of 45. Okay, think about the unit circle if you need to. This is the one I always memorize. I know sine of 30 is 1/2, which means the cosine of 30 must be the square root of 3 over 2. That's how I think about it. The cosine of 45, I know that's square root of 2 over 2. And the sine of 45, also square root of 2 over 2. So if I multiply these together, I can multiply and combine these into one square root. It becomes the square root of 6 over 4 minus the square root of 2 over 4. If you want, you can combine this into one fraction so that it is the square root of 6 minus the square root of 2 all over 4. This is the exact answer. Of course, you could put this into your calculator as well and calculate the decimal answer if you wanted to do that. All right, one more example for you. This one's a little bit more complicated, but it's the same idea. So this time we're given a value for the sine of angle S. We're told that S is in quadrant 1. And we're given the value for the sine of angle T, and we're told that T is in quadrant 3. And we're asked to find the cosine of the sum and the cosine of the difference. You could do this a couple of ways. You could use the identities if you like. I always gravitate towards the triangles first, so I'm going to go with that. But if you'd rather use the identity, you could do that. Okay, I'm going to make a triangle for both S and T. Angle S is in quadrant 1. So if we create a triangle, we're told that the sine of S is 3 over 5. I don't know if you are familiar with Pythagorean triples. 3 squared plus something squared equals 5 squared. There's a 3, 4, 5 right triangle. So you could solve, use Pythagorean theorem if you need to, but that's a triple, right? So what we don't have that we need is the cosine of S. So let's just jot that down. So the cosine of S would be 4 over 5. Okay, let's do the same thing for angle T. Angle T is in quadrant 3. And we've talked a lot about our ability to use a reference angle with the x-axis. So the sine of T, opposite over hypotenuse, would be negative 12 over 13. There's also a Pythagorean triple here. Something squared plus 12 squared equals 13 squared. It's a 5, 12, 13 triangle. But you could definitely use Pythagorean theorem to solve that. Right? We are in quadrant 3, so this actually should be a negative 5. So same thing here. We have the value for the sine, but we need the value for the cosine. So let's jot that down. The cosine of T will be negative 5 over 13. All right, so now let's use that and the formula and calculate the cosine of S plus the cosine of T. So using the formula there at the top, this is going to be the cosine of S times the cosine of T minus the sine of s times the sine of t. And we have these values right here, right? The cosine of s is 4/5. The cosine of t is -5/13. The sine of s, we were given 3/5. And the sine of t, we were also given -12/13. Okay, so now we just want to calculate this, or at least make it a little simpler. While we could cancel out these 5s, we can't do that over here. And so I'm not going to do that right away. I'm going to keep the same denominator so they're easier to combine together. So this is going to be -20/65. We're subtracting a negative, so this is going to be a plus 36/65. -20 plus 16, or sorry, plus 36 will be 16/65. I don't think we're able to reduce that. Okay, let's do the same thing for the cosine of s minus the cosine of t. Let's see how we can do this. Let's do it like this. There we go. All right, so the formula says this is going to be the cosine of s times the cosine of t plus the sine of s times the sine of t the cosine of s is 4/5, and the cosine of t is -5/13. Actually, I guess they're the same, it's just that this is a plus, right? So the sine of s is 3/5, and the sine of t, -12/13. So we're going to have -20/65. This time it'll be a minus 36/65. -20 minus 36 will be a -56/65. And we could think really hard about this, but I'm pretty sure this one also cannot be reduced. All right, well, I hope that gave you a good idea about how the sum and difference formula, how to derive them, and how to use them to calculate various trig values. I hope you'll try this out and make sure that this is something that you can do. We're definitely pulling in skills that we've used before. I think it's very doable with some practice. So I hope you'll take some time to practice this. All right, well, good luck, and we'll see you in the next video.